Hi, my name is Carrie. I'm a mechanical engineering student and team lead for the Pillbox project. As team lead, I handle all communications, scheduling, and weekly updates. I also guide the team in forming a cohesive design and completing all device deliverables. For the prototype, I am responsible for all purchasing and assist in the device build.
My name is Jeff. I'm a mechanical engineering student and have been in charge of fabricating the pillbox as well as the CAD modeling and analysis. During the prototyping process, I fabricated many parts and variations of those parts in order to troubleshoot unexpected issues.
My name is Steven. I am also an ME student for the Pillbox project. I have assisted in developing a functional design for the Pillbox. In the prototyping process, I have contributed in purchasing, machining, and assembling parts for the prototype.
My name is Tom, and I am a senior in electrical and computer engineering. For the Pillbox project, I am constructing a printed circuit board, and I'm taking care of the programming for the control system, the alert system, and the data storage system.
My name is Mike, and I am a BSU senior majoring in electrical and computer engineering. For the Pillbox project, I have been involved in all aspects of the design and test process for the electrical components. I have been responsible for the power supply, the battery, the user interface, which involves the LCD and menu buttons, and creating a pinout diagram derived from the concept of what our prototype should do. In an effort to combat the rising concern for medication abuse, the Pillbox team aims to help reduce this concern by creating a device that helps administer the medicine at appropriate times. Here is the prototype so far. We have robust structure and easily manipulated lids. The compartments also have tamper detection using a sensor, and the lid is securely fastened with magnets. We also implement an alert system with both audio and visual notifications to let the user know when it is time and when it is not time to take their medicine. This information should be retrievable. The data retrieval system will use an SD card to export the data for a caregiver. The programming interface allows for versatile time-taking requirements to be programmed and consists of an LCD display, menu buttons, and a programming switch. We've used pseudocode and flowcharts to speculate on how the overall system should function, and use this to also identify corner cases that need to be addressed. The Pillbox also has cohesive circuitry involving 28 LEDs, 2 microcontrollers, 28 sensors, a speaker, a real-time clock, a power source, and programming buttons. To fasten all of these electrical components together, a custom PCB board and soldered wiring will be applied. The power supply will be a rechargeable battery, as well as a power source that interfaces with the wall, that can, if needed, independently sustain the Pillbox for up to 6 hours of battery life. We've developed a rigorous testing plan to account for everyday encounters that we expect the Pillbox to have. Mechanically, we will be testing to ensure that the lids will stay closed with the magnets we've chosen, as well as activate the sensors. We will also test the device's durability to ensure the device will stand up to 3 pounds of force. From the electronic side, the testing plan consists of checking the battery, checking the alerts, the SD card, buttons, and switch to make sure that they all work together as a cohesive system. We will also make sure that each of these components have enough space to fit inside the Pillbox shell. Completing the construction of the Pillbox will require a few additional steps and modifications. A new lid and handle design will be utilized in order to ensure that all compartment sensors will function properly. The new lids will need to be fabricated and the handles installed. The lids will then be attached to the device using small brass hinges. All openings in the structure need to be made for components that require them, including the DC adapter, volume control thumb wheel, SD card slot, programming switch, speaker, LCD, buttons, sensors, and magnets. Finally, the structure will need to be pre-drilled with pilot holes and prepared for countersinking the screws that hold the Pillbox together. In conclusion, the Pillbox team would like to point out that while it is not a completed product, we are well on our way. We anticipate that by the end of this semester, 2014 of spring, we should have a fully functioning device. Thank you for listening.